Subscribe to Bookworm
and press the bell icon.
Watch various interesting educational videos.
Hello everyone, welcome back to our YouTube channel Bookworm. First of all, I would like to thank all of you for supporting us, and please keep support in near future also. If you want the latest updates for our channel, please follow our Facebook page. Links are given in the description. So let's begin. My name is Dipayan Ghosh and I am back with another lecture video, which is current and electricity. It is an important topic not only for our studies but also our day-to-day life. So let's move forward. This is basically part 1 of this chapter. In this chapter we are going to study the basic concepts, that is circuits, charge, current, voltages, resistance, conductance, etc. I am going to discuss this one by one in this video, so please watch this video till the very end to understand this chapter very easily. So the concept of circuit. What is a circuit? The definition is, the circuit is a path which is always required to get electricity. Specifically, we can say that the path which is required to flow of electrons. There are two types of circuits. One is open circuit and the second one is closed circuit. Here we can see the pictures of open circuit and a closed circuit. The first one is the open circuit and the second one is the closed circuit. In the first picture we can see the switch. Here the switch is open and that's why it is called an open circuit, because the electrons cannot flow from this point to this point. So the net current is 0. So this is open circuit. In the second picture, as we can see, the switch is closed. So the electrons can flow easily from this point to this point. So the current flows in the circuit. So this is called the closed circuit. So the next point is the concept of charge. We all know that when two non-conducting bodies are rubbed together, there is a transfer of electron from one body to another. The body which gains electrons becomes negatively charged and the body which loses electrons becomes positively charged. So thus there are two kinds of charges. One is positive charge and the second one is the negative charge. We all know that two like charges repel each other while two unlike charges attract each other. The charge on a body is denoted by a symbol, that is Q. Next one is the unit of charge. The SI unit of charge is Coulomb and the symbol is capital C. As I have told you earlier, the electricity, which is nothing but the flow of electrons. So the charge of an electron is 1.6 into 10 to the power minus 19 Coulomb. So the next point is the concept of current. The current is defined as the rate of flow of charge. In other words, the current flowing in a conductor is the amount of charge flowing per second across any cross section of it. It is denoted by the letter I. If a charge Q flows through a cross section normal to its direction of motion in time t, the current I through the conductor is given as I is equal to Q by T. The instrument which can measure the current of a circuit is known as the ammeter. So the SI unit of current. The SI unit of current is ampere. So now the question arises, what is ampere? So this is basically same as the definition of current. We have to add the word unity in front of charge and time. So you can easily find out the definition of 1 ampere. So the definition is the current which flows in a conductor when 1 coulomb of one charge passes through it in 1 second. That is called 1 ampere current. So 1 ampere is equal to 1 coulomb divided by 1 second. Now the flow of current. As we all know, in metals there are various free electrons. So if there are n number of electrons in a metal and if E be the charge of the electron, then total charge of the metal or the conductor is equal to Q is equal to N into E. So as we all know, I is equal to Q by T. Then the formula will be I is equal to N into E divided by the time T. So next we are going to study the concept of potential and potential difference. The potential at a point is defined as the amount of work done per unit charge in bringing a positive test charge from infinity to that point. Potential can be positive or can be negative. So the potential is positive at a point in the vicinity of a positive charge, since work has to be done on the positive test charge against the repulsive force due to the positive charge in bringing it from infinity. While if the potential is negative at a point in the vicinity of a negative charge, since the attractive force on the positive test charge due to the negative charge does work done by itself. If W be the work done by the test positive charge Q, then the potential is V, then V is equal to W by Q, or work done W is equal to Q into V. The SI unit of electric potential is volt, which is denoted by the capital letter V. So what is the definition of 1 volt? When 1 joule of work is done in bringing 1 coulomb charge from infinity to that particular point is called 1 volt. 1 volt is equal to 1 joule divided by 1 coulomb. So the unit volt can be written as joule per coulomb also. Next point is the potential difference. This is not same as potential, rather it is the difference between 2 points, say A and B. So the definition of potential difference is the amount of work done in moving a test charge Q from a point A to point B, known as the potential difference between the 2 points A and B. So if VA be the potential at point A and VB the potential at the point B, then VA minus VB is equal to W by Q. So this is the basic difference between potential and the potential difference. The unit of potential difference is also be the same as the unit of potential, which is volt. The instrument which can measure the potential difference between the 2 points is known as a voltmeter. So the next point is the resistance. What does it mean? Resistance is nothing but the obstruction offered to flow of current by the conductor is called its resistance. So what is the cause behind the resistance? We can see from the two picture, that is the first one. As you can see, there is no potential difference across the metallic wire, and the second picture we can see there is a potential difference across the metallic wire. We are going to discuss these two pictures. As we all know that when a metal is formed, its atoms loses electrons from its outer orbit. A metal has a huge number of free electrons. The positive ions in the metals, they do not move, while the electrons move almost freely inside the metals. They move at random motion with colliding each other and also with a positive charge. As there is no potential is applied across the metallic wire, so the net flow of electron in any direction is 0, so the current is also 0. In the next picture we can see there is a potential difference across the metallic wire. So when a potential is applied, the electron inside it experience a force in the direction from the end at negative potential toward the end at positive potential of the conductor. Due to the force, speed increases of the electrons, but during the movement they collide with each other and also with the positive fixed charge and loses some kinetic energy, which increases the temperature of the wire. After the collision, they again accelerated their speed due to the potential difference across the two ends of the metallic wire. The collision also increases and the speed decreases. So this causes the resistance in the metallic wire. Next we are going to talk about a very important topic of current electricity, which is Ohm's law. As we all know, if we applied a potential difference across any conductor, the current flows from the higher potential to the lower potential until the potential difference between the 2 points is same. So in other words, for a continuous flow of current in the conductor at a constant, potential difference has to be maintained across the two ends of the conductor. In 1826, a German scientist, Georg Siemens Ohm, by his experiment found a relationship between the potential difference and the current in the conductor. So what is the statement of Ohm's law? According to the Ohm's law, the current flowing in the conductor is directly proportional to the potential difference applied across the ends of the conductor, provided that the physical conditions and the temperature of the conductor remains constant. So if a current I flows in a conductor when the potential difference across the two ends is capital V, then according to Ohm's law, I proportional to V, or V by I is equal to constant. If we take a proportionality constant here, which is R, then V is equal to I into R. Here R is known as the resistance. The unit of resistance, that is the SI unit of resistance, is ohm, or we can say volt per ampere. So the next point is the conductance. The reciprocal of resistance is called or known as the conductance. It is denoted by the capital letter G. So G is equal to 1 by R. The unit of conductance is ohm inverse, as G is inverse of resistance. So here we can see the graphs. First one is V versus I graph, and the second one is I versus V graph. From the first graph, as we know, this is a straight line, so the equation of straight line is equal to y equal to mx. So from the first graph, we can easily calculate the slope, and from the slope we can calculate the resistance. So V is equal to I into R. Here R is the slope. But in the experiment lab, we never do V versus I graph. We always do I versus V graph. So from the I versus V graph, we can easily find the slope. So I is equal to G into V. Here slope is G. G is conductance, and from the conductance we can easily find the resistance, because resistance is reciprocal of G. So using Ohm's law, we can find the resistance of a conductor easily. Next we are going to talk about different types of resistors. There are two types. One is ohmic and the second one is non-ohmic resistors. So the ohmic resistor, the conductors which obey Ohm's law are called the ohmic resistor. Examples we take all the metallic conductors such as silver, aluminium, copper, etc. For such resistors, the V versus I graph is a straight line graph. So now the non-ohmic resistors. So the conductors which does not obey the Ohm's law are called the non-ohmic resistor. Example: LED, solar cell, junction diode, etc. The graph between V versus I is not a straight line in case of non-ohmic resistor. So these are the basic differences between ohmic and the non-ohmic resistors. Next we are going to talk about the factors affecting the resistance of a conductor. There are four factors. First one is the material of the conductor, second one is the length of the conductor, third one is the thickness, and the fourth one is the temperature of the conductor. We are going to discuss one by one. So the first point is the material of the conductor. So the resistance of the conductor depends upon the material. If the concentration is higher in the conductor, that is the number of free electrons is excess, then the resistance will be less. And if the concentration is less, the resistance will be high. So this is the first point, which is the material of conductor. Second point is the dependence of the length of the conductor. So for a long conductor, the number of collisions between the free electrons with the positive ions will be high, because the length is high of the conductor. Then the number of collisions will be less, so the resistance will be less. So if L be the length of the conductor and R be the resistance, then resistance is directly proportional to the length of the conductor. The third point is dependence upon the thickness of conductor. In case of a thick conductor, electrons get a larger area of cross section to flow as compared to the thin conductor. Therefore, thick conductor offers less resistance. So if A be the thickness of the conductor, so R is inversely proportional to A. Last point is the dependence of temperature. With the increase in temperature of a conductor, the random collisions of electrons also increases. This results the increase of resistance of a conductor. Example we take, the resistance of a filament of a bulb is more when it is glowing as compared to when it is not glowing. What is the reason behind this? As the temperature is higher, then the collision is higher, so the resistance is high in case when it is glowing, and resistance is less when it is not glowing. So these are the main 4 factors of the resistance of a conductor. Moving forward to our last part of this lecture, which is resistivity and the conductivity. So as we have seen from the earlier, the 4 factors depending upon the temperature of the conductor, that the resistance is directly proportional to the length of the conductor and it is inversely proportional to the area of cross section of the conductor. So AR is proportional to L and R is inversely proportional to A. Combining these two, we get R proportional to L by A. If we introduce a proportionality constant here, that is rho, then R is equal to rho into L by A. Rho is called the specific resistance or the resistivity of conductor. So rho is equal to R into A divided by L. From this, the unit of rho, that is the SI unit of rho, can be easily found as ohm meter. Next one, the conductivity. As we have seen earlier, conductance is inverse of resistance. So as the conductivity, that is conductivity is inverse of resistivity. So if conductivity is denoted by sigma, then sigma is equal to 1 by rho. So the unit of sigma is ohm inverse into meter inverse, and the value of sigma is equal to L by R into A. Last we are going to talk about superconductor. This is a special type of conductor. A superconductor is a substance of zero resistance at a very low temperature. Example we take mercury below 4.2 Kelvin, lead below 7.25 Kelvin and niobium below 9.2 Kelvin are superconductors. Superconductors are not in common use since it is very difficult to achieve such a low temperature. However, they can be very useful if it is possible to obtain them at room temperature. Finally, we take some important questions related to this chapter. So, the first question is, how does the resistance of a metallic wire depend on its temperature? Explain with reason. I've already discussed this in this topic. If you do not understand this, please go through the video from the beginning. So the answer will be, when the temperature increases, the collision between the electrons, that is the free electrons, with the positive ions increases, so the resistance will obviously be increased. Example, the resistance of a filament of a bulb is more when it is glowing as compared to when it is not glowing. Question number 2, name a material which is used for making the standard resistor. Give a reason for your answer. The answer is, manganese is used for making the standard resistor. What is the reason? Because its resistivity is quite large and the effect of change in temperature on their resistance is negligible. Question number 3, name the material used for filament of an electric bulb, heating element of a room heater. First one is the filament of electric bulb. A wire made of tungsten is used for filament of electric bulb because it has high melting point and high resistivity. Next is the heating element of room heater. A nichrome wire is used as a heating element for the room heater because the resistivity of the nichrome is high and increase in its value. With increase its temperature is high. Next we take some important numericals. First question is, in a conductor given that 6.25 in 10 to the power 16 electrons flow from one end to another end. Find the current flowing through the conductor. So the number of electrons is given, and we all know the charge of electron is 1.6 in 10 to the power minus 19 Coulomb. So from the formula of current we know I is equal to Q by T. So here Q is equal to number of electrons into their charge. So 6.25 10 to the power 16 electrons into their charge 1.6 10 to the power 19 Coulomb divided by the time is given, that is 2 seconds. We can easily find out the current, which is here the 5 milliampere. The answer is 5 milliampere. The second question and the last one we have taken here is, an electric bulb draws 1.2 ampere current at 6 volt. Find the resistance. So this can be very easily found by Ohm's law. As you all know, from Ohm's law, V is equal to R. Here V and I is given, so R is equal to nothing but V by I. So from the formula we can find R is equal to 5 ohm. So this is the end of this lecture. I hope you all have enjoyed this video. If you have any doubts or any queries, you can write in the comments. I will be happy to answer all your queries. In the next video, I will discuss the second part of this lecture. So please keep supporting us and share this video to all of your friends. So thank you, and I hope you to see in my next video.